Okay, so did we fold our paper in half like a little book? So I think the question was, what should we call this? So let's call it solve by completing the square. But we are taking it up a notch from what we did before. So solve by completing the square. This has kind of a plethora of problems in it. So we're going to have how to complete the square when the a value is not equal to 1. We're going to talk about how to graph those equations, so a throwback to chapter 2. And then we're going to talk about how to solve by completing the square, which will give you another thing in your toolbox for solving equations. Well, last week we did solve by factoring and solve by quadratic formula, right? Oh, yeah, nope, sorry, we're done with that. Well, tomorrow will be a practice day. So we're going to learn new stuff today. Tomorrow you'll do this partner worksheet to practice. And then I think we have like another day of practice this week. And then we're going to solve absolute value equations. And then on Friday, you're going to have an individual, not a team quiz, because your quiz will not have like 4 factoring problems per question. So. Oh, I'm sorry. Oh. Yeah, then we add math. Okay. So rewrite a quadratic in standard form, which looks like this. Y equals ax squared plus bx. Nope, I wrote bc. Plus bx plus c. That is called standard form. We like it for quadratic equation, right? But not so much for graphing. And then we can kind of use this strategy to solve if we are so inclined to do that. All right, so vertex form looks like y equals a times x minus h squared plus k. This form is good for graphing. It is also not terrible for solving. Okay, I prefer it over the quadratic formula, in fact. I'm not a fan of the quadratic formula. All right, we are taking this up a notch from where we were before, because in the past when we completed the square, it was just like y equals x squared. And then stuff after that. Okay, but we had just an x squared. Now we have a 4x squared, and that kind of throws a wrench in how we used to do things. All right, so here's our first step. We are going to factor a out from the first 2 terms. Factor out a from first 2 terms, not the last one, that just hangs out there. So our new equation is going to say f of x equals 4 times, and this better say x squared or we're doing it wrong. And then what would I put next? 4 times what? Yes, 2x. And then you're going to close your parentheses, which is kind of weird. And we're going to leave this minus 5 hanging off the end. So we are going to work on completing the square for the stuff in the parentheses. And this was on your test or whatever we took last week. And I can't say we had a good turnout. So we definitely need to focus on this. All right, so we are only doing the square for the stuff inside the parentheses. We're going to put the x squared in there. Do you guys remember what we do with the 2x? Split it in half. So it becomes x and x. And then we work on the outside of the box. So x squared is made by doing x times x. And then what would go right here? 1. And then another 1. And I am going to handle this almost a little differently than we did before. Okay. So we know that 1 times 1 is 1. Well, maybe we don't. I don't know. We'll see how this goes. Okay. But the thing of it is, how many boxes do I have? 4 boxes. So I'm going to almost imagine this whole thing being multiplied by 4. So instead of a 1 that I need to compensate for, it's actually 4 times 1 or 4. So I tend to just kind of cross this off. and put 4. Okay, so I'm doing 4 times 1 is 4. But I don't have 4, I have -5. So how do I get from 4 to -5? Subtract 9. And then if you need to like make a little note from for yourself, okay, that we're kind of looking at that 4 and the -9 together. So 4 minus 9 equals your -5. Okay, so -5 here, -5 here. And then basically what we've done is we've created a nice pictorial model of how to complete the square there. So we just need to write it not in picture form, but in algebraic form. So f of x equals 4. And then in parentheses, so look at what's in here, inside of the parentheses is x plus 1 squared. That's our box. And then we have our -9 hanging out the end. So what do you think? Manageable or terrible? It's not terrible. We're going to practice a lot more. We have like 6 examples or something today. And then you're going to practice this tomorrow with some other problems mixed in. We'll mix in the factoring and quadratic formula. Now, if we had this equation, can you guys tell me what the vertex is? Just for fun. Good job, Jose. So the opposite of what's in the parentheses and then the -9 hanging outside. Okay, we're going to do it again. The next one. So our first step is to factor A from the first 2 terms only. And then we kind of ignore that last one. So I'm going to have 3, and then what's going to go in the parentheses? No? Oh. Yeah. And then Jose's over here, 2, 4, 3, what? It's a 3, because 3 times 3 is 9. Okay, and then we have our +2, which we're just ignoring for the moment. Can anybody see what's going to be kind of annoying about this box? It is not an even number, so we have a decimal, and that's life, and that'll be fine. So our x squared goes here, and then what goes in these other boxes? There you go, 1.5x. We don't like them, but they're there. They exist in the real world. Okay, so start working on the outside of your box. I know we had a number of kids transfer from a different algebra teacher, and the unfortunate thing is I think all the algebra teachers kind of teach a little differently. We all have our own little techniques. All right, so I have to put a 1.5 and I have to put a 1.5. How do I get what goes in this box? Yep, so check me, but I think it's 2.25. Okay. Now, here's the catch though, guys. We don't have just one of these boxes. How many of them do we have? 3. So we're going to have to do a little modifier for that last number we filled in, because we don't just have 2.25, we have 3 times 2.25. Yeah, 6.75. Okay, how do we get from 6.75 down to 2? I think you're working too hard. What do I need to subtract? How do you get from 6 to 2? 4. So isn't it 4.75? All right, confirmed by Chesney. We are good to go. So whatever this number is here, minus this number should get us back to 2. Okay, so it's always a nice little check that you can do if you're taking your test. So then we just have to write our equation. So f of x equals, we have our 3, and then what goes in parentheses? Yeah, x plus 1.5. It's the outside of the box, and then that's squared because it's a parabola, and then we have minus 4.75. So this would not be fun to graph. We have some decimals involved. What is the vertex, though? Oh, so yes, negative 1.5 and negative 4.75. So always the opposite of what's in the parentheses. Okay, so what do you think? Getting easier? Now, I think we've got some graphing thrown into the mix because we really can't forget that. At the rate we're going, it won't be till after the end of the semester, but chapter 4 is super long. If you haven't noticed, we're technically still in lesson 4.1.1. It basically is like, here, I hope you remember how to solve all these equations that you've ever learned before. So we kind of broke it down a lot. And we have inequalities to do in chapter 4, and the inequalities have two components. So they have the algebraic component, which is what we're going to handle before midterms. And then we have the graphical component, we do later to kind of break up the chapter and make it a little easier. But we'll have to remember how to do all of our parent graphs to graph inequalities. So to keep you informed of what's coming, we can't forget all of these skills. In order to graph a parabola, though, we don't like standard form. It doesn't work well. We can't identify key points. So the directions say, I don't love these directions, but they are what they are. Rewrite into vertex form. Okay, we can do that. State the vertex and create an accurate graph. And then it says you must draw the picture to verify your solution. I'm like, what does that mean? That's what I thought, but now I'm wondering if they're talking about drawing the square. I don't know. All right, so we've got to factor out that A value. I factor out that 2. So what would go in parentheses? You're going to factor it from the first 2 terms. X squared, and then 4x, good. And then our plus 9 just leaves, we leave it alone, stays outside the parentheses. Don't worry about it at the moment. And we're going to do a box for this stuff right here, what shows up in the parentheses. Do you guys want to try to do it? And then we'll check our answers. And then we'll go over the graphing part together for sure. Okay, I'll freeze my screen. don't think you want an X on this guy. You want X on this. We're getting fixed here. Okay, so there was some good questions, guys. So we had a lot of comparisons. Where's my little pen at? There it is. Okay. We had a lot of comparisons between this 4x in the equation and then that last box. So this 4x right here is actually showing up with the 2x and 2x. 2 is kind of a weird number because it, gives you 4 and like 2 squared is 4 and 2 times 2 is 4 and 2 plus 2 is 4 and there's just too much to process there. So this 4x is actually the 2x and 2x. This number is a result of doing 2 times 2. So this 4 has nothing to do with the x term. So a lot of you were trying to kind of rationalize what was happening there. Yes. Yeah, so there are now 2 of these boxes from this number in front. And so because there are 2 of the boxes, we have to adjust what we are compensating for. And so that's why we're making that modification and making it an 8. Because in the past, we did just work with this number here. And so this is the change because we have something in front of our x squared. And so now we're going to think, okay, what do I need to do to get from 8 to what I actually have, which is a 9? And so we have to add 1. And so this needs to get translated to an equation. So our equation is 2 times x plus 2 squared plus 1. What? And we're going to graph the equation. So we have to practice our graphing skills because later we're going to come back around and do inequalities with these graphs and we don't want to forget it all. All right, what's our vertex, guys? Yeah, but there is no way to like graphically solve the problem, I guess. I mean, you could graph it on Desmos and then translate it back, but I don't think that's what they're wanting you to do. They're wanting you to learn some algebra here. Okay, so our vertex is -2, 1. So I'm going to go over -2 and up 1 and put my dot. Now this is where, remember Schoen-Freile's PP power. Okay, so our parent pattern was over 1 from the vertex, up 1, and then over 1, up 3. That's the original. But what's going on with this guy? Is this a plain old x squared or what? We have a stretch factor, right? We have a stretch factor or an a value of 2. And so these vertical changes are going to get doubled. We're going to multiply those by 2. Yeah. Well, we still go over 1. And we're going to go up 2 now. And then we still go over 1 and up 6, and we're going to run out of room. So I should have shifted my axes down, but that's okay. We just know we're up really high at that point. And then you do the best you can to draw a nice parabola. So you're going to take your parent pattern, what your x squared graph does, and you're going to double that vertical change only. And we always keep the horizontal change over 1. Is everybody with me? Everybody graphing their parabola? We'll have to kind of cycle back through and review those parent graphs too, because those will show up with inequalities. Okay, I know today is a boring day of taking notes, but tomorrow there will be no notes and you'll just be practicing with each other. So I try to balance it out a little bit. All right, ready for the next one? This looks pretty bad, but I'm hoping it pans out with that decimal there in the end. Okay, so the first step is to factor out that a value. So we're going to do 3 and then parentheses. What's going to go in my parentheses? Yep. Yeah, x squared, -5, and then keep the x there for the moment. And that 15.75 just gets tacked on to the end. We are not dividing it out. It's really interesting because there are some online videos that have you divide that term too. But I don't think that jives well with our box strategy. So All right. I don't know why I put a sign there. We're going to do a box for just the stuff in the parentheses. So just for this. And then what happens with this one that's kind of annoying. Yeah. And don't forget the negative sign on this one. I don't think we've seen a negative sign yet. So negative 2.5x and negative 2.5x. And then we start working on the outside. So x minus 2.5. And both sides need to be the same because this is called completing the square. And the reason it's called completing the square is because this is actually a square. It has the same dimensions on each side. And so now we have to pick up our calculator and multiply negative 2.5 times negative 2.5. Yes, 6.25. This may work out for us because before we figure out what gets added or subtracted, what do we have to do with that 6.25? Yes, times it by our stretch factor. So I think if I'm doing my mental math correctly, it's 18.75. Yeah. So how do we get to 15.75? Minus 3. So those decimals weren't as scary as they seemed, huh? It all worked out to a nice whole number there in the end. All right, so our equation is 3 times x minus 2.5 squared, and then our minus 3. So what is our vertex? Okay. That's going to be a little annoying to graph, but not terrible. Now I am going to shift my axis down. I don't think we have to worry about moving my axis over necessarily, but I'm not sure how good that is. But I'm going to get my vertex like right on the bottom because my stretch factor is pretty big. And I still will probably do that. Right, so negative 1, so I have to put it like 4 lines up. So that when I put my vertex, it's like at the very bottom. So 2.5 negative, oh, I should have done 1, 2, 3. All right, so we have to start with our parent pattern. Over 1. If I say that enough, you'll remember it. And then what do I have to multiply these vertical changes by? No. A value, the number in front of our x squared is 3. So for this problem, we keep it over 1, and we have 3. And this is where I'm talking about run out of room. Over 1 up 9. Okay, so over 1 is 1, 2, 3. Same thing on the other side. Unless you guys remember that. I move my axis down. And then we do the bus CP. I'm doing a terrible job. It was miserable. I went to no, I don't think this one. Oh, I should try that. You know, thank you. Next time I make a mistake, I will give it a go. All right. So a tall, skinny parabola. Do your parabolas look better than mine? Okay. Yours looks like a V. Yours doesn't look like a V. Well, good thing I look at, whoopsie. Good thing I look at your points. I'll try Angelina's Control-Z trick. Nope, did not work. Yeah, this program's like a little bit different. This is, I think it's just your Internet Explorer PDF viewer, but it's really nice because I can move it and the writing stays like with what it's supposed to stay with. On some of my other programs, the writing like literally is like attached to the screen and the object moves behind it, which is not good. Oh, I don't know where the undo button is. Okay, so we did just changing the form and we did graphing and now we're going to do solving. Maybe. I don't know what that is either. This guy? Rotate right. Nope, we don't want to do that. Becca, did you have a question? Okay, so now we're going to move into solving, which was really the topic of the unit, but I thought it was a nice chance to go back and review graphing because we're going to have to do that anyway again. All right, so to solve it, we're going to complete the square first. Now, okay, what other ways could you solve this equation? We could do quadratic formula, right? We could try factoring. I have no idea. Okay, but we're going to do completing the square because we're going to practice a new skill. Okay, so in this one, you actually don't have to set it equal to 0 if you don't want to. You can, but you don't have to. So what do you want to do? Set it equal to 0 or no? Okay, so let's just go through the process we were just doing right here on the side. So we would take out the 2, right? And make it x squared minus 2x. And then we're just going to leave the 5 alone. And equals 6. And so we're really going to just focus on the side of the equation on the left and just leave the equal 6, and we'll deal with that in a little bit. So we are going to do, we're going to need lots of space. So like plan your space. I'm going to come over here and do my box. Okay. I'm really good at drawing slanted lines today. So we're going to put the x squared in the box. And then what happens with my negative 2x? I'm going to cut it in half, right? Yep, so negative 1x and negative 1x. And then we work on the outside of our box. So x squared is x times x. And we have a minus 1 and another minus 1. And then how do we get this box again? Yeah, we're going to multiply these two numbers. It's not coming from our equation anywhere. And then this is kind of the new thing. How many of these boxes do I have? 2. So instead of a 1, what am I actually going to compensate for? 2. So that gets crossed off and replaced with 2 times 1 is 2. But I really need to make a 5. So what gets added on here? Yes. Okay, so our new equation, and this is where this is different than the other problems because we're going to solve and not just graph or something like that. So I'm going to use this model over here. So I have 2, and then in parentheses, x minus 1 squared, and then plus 3. So I've rewritten this entire side. I used my 5 over here when I compensated and I had a plus 3. Okay, is everybody staying with me? Because this is the new stuff. And then equals 6. Okay, calculators are hopefully handy, right? Because it's going to get messy. We're going to have some decimals now. Now we are going to solve. Huh? It would have had decimals either way, whether it was equal to 0 or not. Yeah. Nothing makes it special. Oh, all right. So this is going to be a new solving problem. New solving process. Okay. So we're going to kind of work. If you remember back in Algebra 1, or maybe even before that, they talked about different ways to solve problems. And one of the ways was called undoing. So we have to undo what happened to x to solve for it so that we don't have to do the quadratic formula and we don't have to factor. So does it make sense that I would minus 3 from each side of my equation? If I'm trying to get x by itself, that 3 needs to go, right? Okay, so I'm going to minus 3 to both sides. So now I've got 2, and then x minus 1 squared, and now it equals 3. What else do I have to get rid of to work towards getting x all alone? The 2. So that's really 2 times that quantity. So how do I undo multiply? Okay, so I'm going to divide each side by 2. So x minus 1 squared equals 1.5. Now what do I need to undo? The squared, yeah. How do you undo squared? Square root. All right, now this is where it gets tricky, guys. We get 2 cases. This is very specific to undoing an x squared and to absolute value, which we'll see later in the week. So we're going to get x minus 1 equals, what's the square root of 1.5? Who can figure that out for me? $1.22. All right, let's go with 1.22. And then we're going to have x minus 1 equals negative 1.22. So you need to write down that we get two cases. Write that down. Two cases. Okay, now that makes sense, right? Think about the quadratic formula. Do we have a plus or minus the square root in the quadratic formula? Right? So we have two cases with the quadratic formula. When we factor, how many sets of parentheses do we get? Usually two. And so we end up with two answers, right? So doing this positive negative case gives us our two different answers. Just like in the quadratic formula, we have plus or minus the square root. Same here, plus or minus the square root. All right, then we have one more step. We're just going to add 1 to each side. So we get x equals 2.22. That's one answer. And add 1 over here, x equals negative 0.22. And then there's our other answer. So it's a new way to solve quadratic equations. What do you think? Thumbs up or thumbs down? It was okay. Well, yeah, sometimes yes and sometimes no. I'm not sure what I'm going to do on your quiz, whether I'm going to say solve however you would like, or if I'm going to say you must solve using the quadratic formula. I'm not sure. Yep, those are your answers. I'll have to decide how that's going to look, Angelina. Okay, so find the x-intercepts by completing the square. So same type of problem. All right, so let's go. Let's get it done, and then we're done with notes for today. I know, one day of torture. Tomorrow you'll be able to work with your friends and not listen to your teacher talk all day. All right, so we're going to take out the 4. Oh, this is different. Wait a second. It says find the x-intercepts. What does that mean we have to do? Okay, whenever you're finding an intercept, you're going to make the opposite variable 0. Okay, so if I'm finding the x-intercepts, what variable is going to become 0? Y, the opposite. Okay, find the x-intercepts, make y equal 0. In this case, y is f of x. So 0 equals 4x squared minus 8x plus 1. 0 equals 0. You're so insightful today, Angelina. Okay, so we're going to factor the 4 out from the first two terms. So I will have x squared, and then if I factor the 4 out of this, minus 2, yeah, you're right. I almost put minus 4x. Good thing you were here to stop me. Okay, so now we're going to do our box. I'm just going to do it off to the side because we're going to need our space for problem solving. So we put our x squared in there, and then we have to cut this guy in half. So I'm going to have negative 1x and negative 1x. I feel like that's super similar to the last problem. We also had negative 1x. It's weird. Okay, so x squared is x times x. And then what do I put in this spot? Negative 1. Is everybody bearing with me for our last example and making sure you're still paying attention? Okay. All right, this, remember, has nothing to do with the printed equation. This is actually negative 1 times negative 1, which is 1. Yeah. Now, how many of these boxes do we have? 4. So when I go to compensate to make this plus 1 out here, I'm not using the plus 1 that's in the box. I really have a 4 here because I have 4 times 1 is 4. Okay, and now I need to make 1 minus 3. Okay, so now we've used the 1, and we're going to rewrite our equation, and then we're good to solve. Now, I will tell you that on your quiz Friday, I would probably not give you something like this and say, solve by completing the square. I would probably give you something that looks like this form. 0 or maybe a number equals 4, and then times x minus 1 squared minus 3. I'd probably give it to you written like this. And then that's a big clue that you're going to want to use completing the square to solve, or use this undoing process to solve. You didn't really have to complete the square, but it looks like that format. Okay, so how would I work backwards to get x? What would I have to do? What do you want to do to each side of your equation? to solve. Yeah, add 3 to each side because we're working backwards to get x all by itself. So now we've got 3 equals 4 times x minus 1 squared. What should we get rid of next? The 4. So we're going to undo this multiplication by dividing each side by 4. Okay, so you can leave it as 3/4, but because I know we're going to have to take the square root, I'm just going to go ahead and use the decimal and put 0.75. So that equals x minus 1 squared. What's our next step? Yeah, so we have to undo that exponent. So this is when we do our square root, and this is when we come up with our 2 cases. So we're going to have the positive square root and the negative square root, just like the quadratic formula. So x minus 1 equals, and then x minus 1 equals, and we're going to figure out what the square root of 0.75 is. We have to do one positive version and one negative version. And if we can get into that habit now, like absolute value works in a very similar way later in the week. What's inside here, this x minus 1, that does not change signs. It's literally just the answer. So when you do the square root of 0.75, this is what gets the positive or negative. So 0.87 and negative 0.87, just like the quadratic formula, plus or minus the square root. Now we just have to add our 1 to both sides. So x equals 1.87. That's one answer. And this does, I cannot mentally add 1. Is it 0.13, I think? I'm going to double check myself. Yes, 0.13. And then there's our other answer. Okay, any questions?